Hey there, scientists. Today, you are going to use evidence to support the argument that plants get the materials they need for growth chiefly or mainly from air and water. Let's do this, scientists. Welcome back, scientists. I'm Mr. Steier, and this is Mr. Steier's Classroom. As you know, we have been talking about hydroponics and determining if plants can get all of the materials they need for growth chiefly from air and water. And we're trying to prove that here with our experiment that we started in our last lesson together. Now, the first thing that I hope that you guys have noticed is I hope that you have been able to make some observations about what has been happening in your hydroponics experiment. Now, as a scientist, you have to remember this is an experiment. You are trying to prove something. There is not a guaranteed outcome, and as part of the process, we are learning from it. Remember, we are scientists. We are critical thinkers. We are aware of what we're looking at. We're aware of what we're asking, and we're trying to learn carefully from every one of these experiences. One of the things we're going to talk about today is we're going to talk about the difference between an observation and an inference. So first of all, I know that you have been recording your observations of your hydroponics experiment. And immediately we can make some observations right here. I can observe that my water is brownish in color. I can observe that my rope or my cording is wet. And remember, that was our goal because it means that it is keeping my seed wet. The water is wicking up and keeping my seed wet. Because again, the question is, from air, water, and sunlight, can a seed grow? I can observe that my cotton balls are still damp, so I know that there's water up there. I can observe that there's condensation inside of this top cap. I can see some water in there. I can, if I marked the water level, which I know some of you did, if I marked the water level, I can observe that the water is not at the same level that it was before. Now, on my other cutting where I tried to grow a plant or sustain a plant hydroponically, not really grow it, but one of the things that I can observe is my water is a little bit darker. There's maybe some more discoloration to the water there. And I know you're not going to be able to see this, but I can observe that inside of there, on the stem, I can see that there is 1, 2, 3 parts of these 4 parts of this stem where it's been cut, where roots are starting to grow out of the stem. I can see white roots emerging from, and it's really coming from where these little bumps are on the stem, that it's starting to root. So those are my observations. Those are the things that I can see, I can know, I can observe. Well, now I can take that information about what I observe and I can make some inferences. Now remember, the difference between an observation and an inference is an observation is information that is gained from your senses. So it's things that you could see, you could smell, you could taste. Your inference is how you're interpreting that information. So as a scientist, how is the information that you're getting changing or increasing your understanding of your experiment, of your goal, of your process? Well, in this one of my inferences is that I can infer that my seed is not growing because the cotton balls were too wet. If I look really closely in there at my seed, I can actually see that the seed coat burst on it, which is that's good, but it does look like there is some mold. I can observe there is some mold, and if there is mold, then that's my observation. My inference is the seed was too wet, or I might infer I packed it too tight, so the seed could not burst out of the cotton balls. Those are inferences that I can make from my observations. Those are really helpful if I were to try this experiment again to attempt to prove if plants can get the materials they need for growth chiefly from air and water. Now, if I come over here to my cutting, where I told you that I have multiple parts of this plant that are just in water and rooting, I can infer based on these observations, I can make an inference that the plant is getting what it needs chiefly from the nutrients that are in the water and from air in order to be able to grow. Now, I might also have to make an observation that when I keep this on the shelf behind me, that it's getting enough sunlight. I can infer that it's getting enough sunlight because I can see growth I can see growth of those roots. Now, as I continue to observe this, and as you continue to observe your hydroponics experiment, I really encourage you to make certain that you also look at the leaves if you did a cutting, and note closely, like today when I look at it, how many roots do I see forming? How long do I think they are? About the size of an eraser on a pencil. And then I need to make sure that I'm understanding and charting, and I'm being a critical consumer of this information that I can observe to know what changes are taking place. So it is crucial that you understand the difference between making an observation and making an inference as we move forward to support this argument. So you know that recently we have been spending a lot of time studying plants. We learned how plants make their own food, and I know you know how plants make their own food, and I know that you're singing it in your head. In fact, it is photosynthesis. And that is how plants make their own food. So if plants can make their own food, again, it leads us back to that question. Can you use evidence to support the argument that plants get the materials they need for growth chiefly or mainly from air and water? And we know plants make their own food through photosynthesis. So what do you learn in the investigation about hydroponics? Well, what are you learning? You have multiple different answers here. Like I may have been able to learn that I packed my seed too tight in those cotton balls. Maybe you learned that using a piece of cotton t-shirt did not work for a wick for the water to rise up and keep that seed wet. Maybe you're learning that you needed more nutrients in your water, that you used super purified water, and that did not help. Or maybe you learned that you used super purified water and that did help. All of these observations, all of these things that you're learning, they're just part of you being a scientist. So if we move forward as we're trying to create and support an argument, again, our work today leads us into just looking at this picture here. So the first thing we can do is we can just make observations of this photo right here on our page. We can observe that there are pipes on a bamboo fence. We can observe that the pipes are gray. We can observe that some of these plants are red and most of them are green. We can observe that this is a picture of a hydroponic system. Oh, wait, do we know that? Is that an observation? Can we actually prove that just by looking at it with our senses, with our sight and with our hearing? Or would that be an inference? Would I be using what I know and what I can see from this model, from this picture, and can I make an inference of what is actually happening? So I might infer that these plants are growing hydroponically. I might infer then, because I can't see or know, I might infer that there is water in each of those pipes. And I might be able to use those inferences and those observations to make an argument that plants can chiefly get the nutrients and the materials they need from air and water. So again, when we look at this picture, what are the observations you make? What are the inferences that you can make from this image? Because we're asking ourselves, how are these plants getting the materials they need for growth? So far, we've talked about orchid plants. We can see bamboo here. We know that corn plants are all very different from each other, but they all need to take in materials for growth. Because most of those plants grow in soil, many people think plants use soil as a building block for their growth. So how can you support an argument that describes where plants get the materials they need to live and grow? Now, when you do this, when you get to your activity this week in this lesson, you have to prove with evidence how you are coming to your conclusion. Scientists do not just say, it is because I say it is. Scientists say, here are the facts that I have to prove this thing. So I made all of these observations. My observations led to inferencing, and then I can make a theory or I can make a proof after I have collected that data. And what we're doing today is you're listing in your mind, you're listing in your science notebook that you're keeping, what are the materials that you believe that plants need to live and grow? Okay? And then what examples of evidence did you use to come up with that? So maybe your example is from one of the videos that you've watched previously. Maybe it's from one of our previous lessons that you can say, in lesson 5, when we talked about what are materials that plants need, we understood that plants do not need soil. Okay? Maybe you're going all the way back to the orchid and you're saying, hey, that orchid in our very first lesson about plants, and that orchid, it was growing on the top of a tree. So that is a specific piece of evidence that you could use and then quote exactly from the text what it says there, like in order to prove that you have an argument. Okay? So remember, you're taking all of the information that you know right now from all of the lessons that we've done so far about plants, and you have to create an argument. And you have to support it with evidence from a text, from a video. You have to support that from a researched material in order to prove that plants can get the materials they need for growth from air and water. All right. So step 2 in this argument process is you need to compare that list. You need to think about has that list of what you have determined that plants need, has it changed over time? Have our lessons changed in their delivery of the information from the first orchid lesson to our hydroponics experiment. And then you're going to take that information and you're going to construct your argument. So what you're going to do is you're going to explain why a plant must have the material to live and grow, or why the plant does not need that material to live and grow. So, can you prove with evidence from a previous lesson that plants do not need water in order to grow? Can you prove that plants do not need air in order to grow? Can you prove that plants do not need soil in order to grow? And then your last step in the process is to make a generalization. So this is the point where you're coming up with your theory, you're coming up with your hypothesis based, your conclusion based on your hypothesis at the beginning. Because what you ask yourself is, can I come up with enough evidence to support the argument that plants get the materials they need from air and water? And then you're making a generalization. You're saying, because of this element, this thing, and this thing, in this book, in this video, and this experience, I can generalize that plants can or cannot grow chiefly from the materials in air and water. This is the essence of all of the scientific work that we have done to this point. This is where not only does a scientist do experiments, and not only does a scientist do research, but a scientist is also very much a writer. A scientist is also someone who is a critical thinker and is able to put together all of the pieces from their research, from their experiment, and from their understanding to create something to help others understand as well. And that is what you're trying to do now. You're taking your research from the beginning, your experience with the hydroponics experiment, or your observations from my hydroponics experiment, and you're putting all of that together to create understanding that you can share with others. This is a big task. This is an important task. This is your responsibility as a scientist to do this well and to do this critically. When you look at the activity, make certain that you look at the example that was written for you. You can see in there how I quoted from the text, and you can also see in there how I referenced the text in order to have a factual piece of evidence of where I'm getting my ideas from. Thanks for being here today. Remember, I am Mr. Steier. This is Mr. Steier's classroom, and have a great time.